Theorem number 18. Theorem number 18. Write it. Under theory number 18, write the sentence. Under theory number 18, write the sentence. Under theory number 18, write the sentence. Write the sentence. Under theory number 18, write the sentence. The reflection of a point on a straight line segment. So I'll take an example. We have a straight line segment like this. We have a straight line segment like this, and we will give a name for this straight line segment. 4x plus 3y plus 7 equals to 0. I'll give a name for this straight line segment. Let's take the straight line segment as u. Okay. In papers, you will see the u is written. Okay. So write you can draw this with me. Draw and write. U is equals to 4x plus 3y plus 7. We'll take 4x plus 3y plus 7 equal to 0. Okay. On this straight line, the reflection of a point on the straight line means actually we are not taking a point on the straight line. Reflection is going to be on the straight line. On what or not actually on the straight line. Okay. Actually, the translation from the Sinhala is going to be on, but actually it's not going to be literally it's not going to be on top of the straight line. It's like when there is a point outside the straight line segment. Let's take the point as capital A point. Okay, so I will take usually will take capital O. Okay, I'll take O, and the coordinates are 4, 5. 4, 5. I take a point outside the straight line segment 4, 5. So this point's reflection on the straight line segment is what we are going to calculate now, or as the position of it. Where the reflection of this O. So which means we are thinking that the straight line segment as a what? As a mirror. Okay, as a mirror. So we know if you see your reflection in the mirror, we actually say our reflection is on the mirror, right? That's how we say. Verb or general use. So our reflection is on the mirror. So on the mirror means that doesn't mean we can touch the reflection, right? So there's a point which has the same properties as this point capital O, but not here exact point, but it's in a different position. But that position is going to be here. Understand the practical situation. This one acts like a mirror. This one acts like a mirror. So I'll draw like this. In O-level science, I hope you are familiar. When we draw lenses are mirrors. Darpana kila kata karanne convex, concave mirrors, concave mirrors, and then I don't know what are the names that you are giving for them. Convex mirrors and then flat ones. What's this highlighted area? That's the area where you apply the mercury, no? Right? So this side becomes the glass mirror. So like that. So here in front, this straight line segment, we'll assume that as a mirror. Practically, it's not a mirror. No, it's a straight line segment. Let's say it is a mirror. In front of it, we have a point capital O. The perpendicular distance from point capital O to the mirror. Let's take this point as M. From this M, if you take the same distance, whatever distance we have here, the same distance if we take, at the same distance we have another point, I'll take it as O dash, which is going to be the reflection of O. Our target is to find what is the XY coordinate, what are the X and Y coordinates of this. We are trying to identify the position of that point. That's the goal. That's our goal. Okay. So In order to identify the position of position of that point, in other words, the coordinates, locate that point, we are going to do a small exercise. So quickly draw this one, and below that write the questions. I'll give them as a question. You can use your previous classes knowledge to solve the question. I will also do it with you. First of all, draw this one nicely and write down the first question. Draw this one and write the first question. Question number 1. We'll consider the gradient of this one as m1. I'll join O and O1 points, and we'll take the gradient of this O01 straight line segment as m2. I'll take the O01 straight line segment's gradient as m2. Okay, so write like that. Draw quickly. And if you didn't draw, you can draw it. First of all, write the question now. Write the first question. Find the gradient m1. Question number 1. Find the gradient m1. Question number 2. Find the gradient m2. Find the gradient m2. Find the gradient m2. Find the gradient m2. Third one. Find the gradient m2. Write the next question. Third one. Third one. Get the coordinates on O01 straight line segment. Get general coordinates. Better write like that. Get general coordinates on O01 straight line segment. Sorry, OO dash. OO dash straight line segment means this. Get the general coordinates on O01 straight line segment. O01 straight line segment. Parametrically. Question number 4. Hence, find the coordinates of point O dash. Hence, find the coordinates of point O dash. Find the gradient of m1. So let's take the first question. Gradient m1. So we know the equation m1 is the gradient of straight line segment u, no? What is the equation of the straight line segment u? 4x plus 3y plus 7 is equals to 0. So if you want to calculate the gradient, what's the idea? Write this one y equals to mx plus c format. Then you will have to take plus 4x to the other side, minus 4x minus 7. Divide both sides by 3, you will get minus 4 over 3 minus 7 over 3. So therefore, m1 gradient is given by minus 4 over 3. No? The coefficient of x term is the gradient. This is all ours. Second one, what they ask, find the gradient m2. We know that if two straight line segments which are not parallel to the x-axis or y-axis, obviously these are not parallel to the x-axis or y-axis. Why is that? If this is parallel to x-axis, If this is parallel to x-axis, what happens? Puta make x-axis parallel now. The equation is going to be y equals to something. X එකක් ඉන්නේ. If this is parallel to y-axis, it's going to be x equals to something. That kind of an equation. So obviously these two straight line segments are not parallel to the x-axis or y-axis. If two straight line segments not parallel to x-axis or y-axis are intersecting each other, mutually intersecting each other perpendicularly, the product of the gradients is going to be -1, no? If two straight line segments are not parallel to x-axis or y-axis, and if those two are perpendicular to each other, the product of the two gradients is going to be -1. M1 gradient is equals to -4/3 multiplied by M2. This is equals to -1. So M2 is equals to, do the cross multiplication, 3/4. So the gradient M2 is equals to 3/4. Third one. They asked us to find the general coordinate on OO1, so OO dash parametrically. Was the process of identifying the parametric coordinates of a straight line segment? First thing, we start with the process of calculating the equation. What's the process of calculating the equation? We know the gradient. We know the gradient. This is -4/3. This one's gradient is 3/4. We know the gradient. So let's consider any point on OO dash as x comma y. So you have to write that. Consider any point on OO dash x comma y. X comma y are any points on coordinates of any point on OO dash straight line segment. Now using that general coordinate and the known coordinate, we can write the gradient. No? What's the gradient? A difference of y coordinates. Capital O point is on the OO dash straight line segment. So I'm taking this general coordinate and this coordinate. So difference of y coordinates divided by difference of x coordinates, x -4, is equals to the gradient of OO dash straight line segment is 3/4, which is M2. Now, after this step, what did we do? Special cross multiplication. If anyone can recall it, what's the special cross multiplication we did? We just sent this x difference of x coordinates to the other side, took this constant here. That's it. Y -5 divided by 3 is equals to x -4 divided by 4. There's a special cross multiplication. This one's basically the variables sent to the numerator. This one sent here. This 3 came here. Now, y is a coordinate, a real number divided by a real number is a real number. This is a real number. So this equal sign says that this is a real number, this is a real number. So I'm going to take them as simple t. This one gives you a value, that value is equals to this one. So I'm going to take that value as simple t, where we write as t is a parameter. T is a parameter. You must write that. So we did the same process in our previous classes. This one kind of a recap for you. Here, now upcoming theory parts are actually going to have the help of previous ones. Not heavily, but idea. So I'm doing such way that you can recall the process. Even if you can't recall it, now try to understand the process. I will take this one as the first equation, this one as the second equation. So you get y -5/3 is equals to t. This one implies, this is not an equal sign, this is an arrowhead. I already told you, instead of wasting another step for this, Putting an arrowhead is okay. In front of that, we can write subject by and write subject by directly do your A-level students. Do the simplifications quickly. 3 times 3, 3t minus 5, take the other side plus 5. We get y equals to 3 simple t plus 5. We got the y coordinate parametrically. So let's take the second equation. This is from 1. We'll take the second equation. What is it? X minus 4 over 4 is equals to t. Okay. X minus 4 over 4 is equals to t. This one implies that x equals to 4 simple t plus 4. So therefore, parametric coordinates on OO dash, I will just erase the questions, are going to be x coordinate is 4 simple t plus 4, comma 3 simple t plus 5. What is the meaning of parametric coordinates? Parametric coordinates gives you any coordinate on this OO dash. By substituting different values to this t, you get a pair of x and y coordinates. Obviously, that x coordinate and the y coordinate must be on this OO dash. You can substitute any value to t. Can be a whole number, it can be a negative whole number, it can be a decimal, it can be any rational value or irrational value. Any value to t, if you substitute it, you will get an answer here, you will get an answer here. That coordinate, x comma y coordinates, that x coordinate and the y coordinate is going to be a coordinate of a point which is obviously on this OO dash. That's the idea of this. So now, there is a, listen now, there is a value for this simple t. The simple t can take any value. Listen carefully. This is the place where most of the students get confused. Now stop working and listen. I'll give you time to write. The make a meet avada hemming karanda bear. So stop working and listen. Please concentrate. If you keep your mindset, no, I'm not understanding, kila mindset එක තියාගෙන හිටියොත් ඉතින් මෙතනට ඇවිල්ලා කවුරු කියන්නවත් තේරෙන්නේ නැහැ. Try to keep your concentration and put the words one by one into your head and try to connect the dots. If you are trying to do this like in all of us, if you get this, do this. If you get this, do this. If you get this, do this. Those kind of algorithms won't work in A levels. Okay, I have told you this one many times in the classes. This one, A levels, every theory is a new theory. Every connection is a new connection. You have to connect it dot by dot. So maybe understand karne unta neural networks development amaru wende be. Right? What are neural networks? You find it later. Now there are people here. We are doing IT because I want to do software engineering, sir. Right? And neural networks monadi level danne. But want to be a software engineer. I want to do data science. What are neural networks? Don't know. Right? Pathetic. Hari? Enthusiasm එක තිබ්බට තේරුමක් නැහැ. Curiosity එක තිබ්බට තේරුමක් නැහැ. Okay? You have to know the things. So now මෙතන මොකක්ද වෙන්නේ? We are connecting the dots. Right. So we know that simple t is a parameter. Who is a parameter or what is a parameter? It's a number. It's a number. Parameter is a real number. So that number t can take any value. It can have any value. When t is equals to 1, we get 4 times 1 plus 4. 4 times 1 is 4 plus 4 is 9. 3 times 1 is 3 plus 5 is 8. 9 comma 8. What is 9 comma 8? One of the points on this OO dash. When t equals to 0, 4 times 0 is 0. 0 plus 4 is 4. 3 times 0 is 0. 0 plus 5 is 5. 4 comma 5. How do we 4 comma 5? A point on this OO dash. 4 comma 5. So like that, if you want, you can substitute t equals to 0.5 or is half. Let's say 0.5. So it's going to be 4 times 0.5, 2. 2 plus 4 equals to 6. 3 times 0.5 is going to be 1.5. 1.5 plus 5 is equals to 6.5. This is going to be 6 comma 6.5. Another point on this xy, this OO dash straight line segment. We can have not always whole numbers are points. We can have different points. Decimal value points there are coordinates. We take only the whole number coordinates to make our calculations easy. Otherwise, we can't say there are points which doesn't have, obviously there won't be any points which has decimal values. X coordinate can be a decimal value, Y coordinate can be a decimal. Actually, X and Y coordinates can be irrational values also. Not rational, irrational values will not පුළුවන්. තියෙන්න පුළුවන්. These are on XY coordinates plane. Infinitely many real numbers are there. So, however, idea is t can be any number. By substituting a value to t, we get a point on this OO dash. Coordinates of point on this OO dash. So t has a value. For that value, we get a particular point. When t is 0, we get this point. When t is 1, we get another point. When t is 2, we get another point. But everyone is on this OO dash. When this t gets a value, there should be, there must be a coordinate for O dash. Shows why O dash point is on this straight line segment, no OO dash. So O dash points coordinates can be found if I know the coordinates of what? If I know the, OO dash points, O dash points xy coordinates can be found if I know the value for t that I have to put, no? So we know when t, what's the value for t that we have to put in order to get this? We notice that, no, 0. When 4 times 0 is 0, 0 plus 4 is 4. 3 times 0 is 0, 0 plus 5 is 5. So this is 4 comma 5. When t holds the value 0, we get O point. Like that, t holds what's value to get the O dash point? That's the question. Do we know this value? Done. This is a parameter. Parameter should hold some specific value for that specific point. That specific value we don't know. We don't know that specific value. That's why we consider that specific value as capital T. I hope now you all are clear why I am considering capital T. This simple T can get different values, but this capital T is only one value. Either 1 O, either 2 O, either 3 O, some specific one value for this O dash. This is dedicated only for O dash. This simple T is dedicated for everyone. When this simple T takes 0, it gives you only capital O point. When simple T equals to 1, it gives you another point. When simple T equals to some value, it gives you only O dash point. That some value which gives only A dash point, we don't know. That's what I am taking as capital T. We can't keep it as simple T and solve. Even though you get the answer, no marks. Why you didn't use the proper idea of parameters? When t gets a specific value, that value is when t gets a specific value, to that value corresponding coordinate is O dash. Such way that specific value for this O dash we have to find. So I'm thinking my assumption is for the fourth question, assume when simple T equals to capital T, we get coordinates of O dash. Then I can write O dash coordinates. This is how we write coordinates. You can put 3 lines like this. When T equals to capital T, I'm thinking points of O dash point is I'm getting. So for capital T plus 4, comma 3 capital T plus 5. This simple T, this parametric coordinates can be anything. But this one is not a parametric coordinate. This is a specific coordinate. only for O dash. Move O dash to විතරමයි අයිති හරි. Move O dash to විතරමයි අයිති. You can't say this is the coordinates of capital O. No, capital O के coordinates will t වෙන value එක. Simple t when it is equals to capital T, this is the coordinate, this is the coordinates, the pair of coordinates we get, and this is the only, this coordinate only for O dash. අන්න එක තමයි idea එක. මෙතන not only for O dash, this is for everything, right? Then කවුද මේ? We found the coordinates of O dash point parametrically. කොහොමද පුතා? For capital T, not parametrically. Parametrically, we found this. We know the coordinate of O dash points when the parameter value gets a specific value. I need to find this capital T. It should be a fixed number. That fixed number I don't know. We have to find it. Plus 4, comma 3 capital T plus 5. Then බලන්න ඕන how I can do this. Right. Then ඕක කරන්න නම් the process එක ලොකුයි. We need to identify the coordinates of capital M point. We need to identify the coordinates of capital M point. Using that, we can find the value of capital T. Right. In order to perform those steps, I need more space on the board. So I'll have to erase it. So quickly, if there is something to write down, write it down. And then after that, drop a message in the chat box as done. I will start the discussion. After all this, now let's take a quick summary. Let's take a quick summary of what we have done so far. All right. So I need the calculation to do on this side. So I will redraw this here. Now we know this is a straight line segment. U, the name is U. 4x plus 3y plus 7 is equals to 0. Basically, U equals to 0 equation. And the gradient of this straight line segment, we found it. It's equals to minus 4 over 3. So O dash straight line segment, which is perpendicular to this one. O points coordinates 4, 5. O dash points coordinates, we found it in terms of capital T, 4t plus 4, 3 capital T plus 5. Right. So we need to identify the coordinates of this capital M point so we can find the capital T value. Why? How? කොහොමද ගන්න පුළුවන්? This one's 3 over 4. Right. 3 over 4. Right. So I need to identify the coordinates of this capital M point. We can identify it directly in terms of capital T. How is that? This is a midpoint. No. Why I can say midpoint? This is a reflection point of this capital O. No. So this distance is equals to this distance. OM distance is equals to MO dash distance. Therefore, M is the midpoint of OO dash. So the coordinates of capital M can be written how? How to find the coordinates of a midpoint? Add the x values, divide by 2. 4 plus 4t plus 4 divided by 2. 4 plus 4t plus 4 divided by 2. Comma, how to calculate the x coordinate, the y coordinate? 5 plus 3t plus 5. 5 plus 3t plus 5 divided by 2. So we can write the capital M points coordinates. 4 plus 4t plus 4. This is 8 plus 40. Divide by 2, you will get 4 plus 2t. 4 plus 2 capital T. Comma, we get this one, we get 10 plus 3t. No? So I'll just keep the denominator 2 just for the simplification purposes. No any other reason. 4 plus 4, 8. 8 plus 40 divided by 2, comma. 5 plus 5, 10. 10 plus 3t divided by 2. 10 plus 3 capital T divided by 2. Okay, divided by 2. Now, listen carefully. What did I found? The coordinate of capital M point with the help of these two. And we discussed this one in the second or third theorems, as I can remember. Second theorem, no? Second theorem. Not theorem, second theory. We discussed that. Now, I can find the same endpoints coordinates exactly if I know the equation of this straight line segment, no, sorry, OO dash. So, I'm going to find the calculating the equation of OO dash. How to find the equation of a straight line segment? Consider a general point on the straight line segment as x comma y. The gradient using the general coordinates and a known point y minus 5 divided by x minus 4 is equals to the gradient 3 over 4. What I'm doing, I'm finding the equation of OO dash, not the parametric coordinates, okay? When we find the parametric coordinates, what we do? We do a special cross multiplication. Just normally do it. 4 times y minus 5 is equal to 3 times x minus 4. So this is going to be 4y minus 20 is equal to 3x minus 12. Take all the terms to one side, or I'll just keep the constant on one side. 3x minus 4y is equals to minus 8. Okay. So this is the OO dash straight line segments equation. Okay. We'll take it as 1. I'm going to take the U straight line segments equation here. What's the equation of U straight line segment? 4x plus 3y plus 7 equals to 0. So let's take plus 7 to the other side, minus 7. So U straight line segments equation is 4x plus 3y equals to minus 7. This is my second equation. I'm calling the U equation again here, okay? I'm calling the U equation again here. By taking the plus 7 to the other side as minus 7. That's the only change I did. Now, what's the idea? If you know the equations of two straight line segments, or as equation of the two intersecting straight line segments, by solving the two straight line segments, the value you get for x and y is going to be the xy coordinates of the unknown point, no? So it's not unknown point, xy coordinates of the intersection. Sorry, it's not unknown of the intersection point, no? If you solve the equations of non-parallel straight line segments like a simultaneous equations, the solutions you get are going to be the xy coordinates of the intersection point. Xy coordinates of the intersection point. Then go. This is 3x minus 4y equals to minus 8. 4x plus 3y equals to minus 7. So I can see by multiplying this one by 3 and this one by 4, and then if you add it, y is cancelling out. Now this is O level, simultaneous equation simplifications. Do it. But under first equation multiplied by 3 plus second equation multiplied by 4. I'm going to multiply the first equation by 3. We get 9x minus 12y. Add karana. Second equation multiplied by 4, 16x plus 12y. This equals this one multiplied by 3 minus 24 minus this one multiplied by 4 minus 28. So we get minus 12y plus 12y cancelling out. 9 plus 16 is 25y. This is equals to minus 24 minus 28 is equals to minus 48 minus 52. Minus 52. Divide both sides by 25. Y equals to minus 52 over 25. That's the y coordinate of this M point. Now you can find the x coordinate what I can do is multiply this one by 4 and multiply this one by 3 and subtract them, no? Our first equation multiplied by 4 minus second equation multiplied by 3. Subtract them. So you can ask me, sir, can't we just simply substitute this y to one of the equations and get? ගන්න පුළුවන් මම කැමති නෑ. මම මේ වැඩේට කැමති නෑ. You also don't do it. Can do, but I personally don't like that. හේතු තියෙනවා. සහේතුවයි. There are reasons for that. Okay. I personally don't like substituting in some. If the equations are simple, I will do it. දැන් මෙතන ගත්තු values ලොකු හින්දා මම මෙහෙම කරන්න යන්නේ නැහැ. So let's multiply these two. This one by 4. Sorry, this one by 3 and this one by 4. Sorry, this one by 3 and this one by 4. Removed y, no? This one by 4 and this one by 3 will multiply. The coefficients of x are equal. Ne? Sorry. I want to remove y now, no? Sorry, I made a mistake. This one is x. Make a x. Amme y wa kapala y kila liyala. X. Sorry, my bad. My bad. Okay. So balanna my simplifications waraddu tari. Now listen. Now I can multiply this one by 3 and this one by, sorry, these two, no? These two. I want to remove x. So multiply this one by 4, this one by 3 and subtract them. This one by 4, if I multiply, we get 12x minus 16y. Subtract, multiply this one by 3, 12x plus 3y. This is equals to, multiply this one by 4 minus 32 minus, if you multiply this one by 3, you get minus 21. Okay, no? Simplify, 12x cancelling out, we get minus 16y minus 3y minus 19y is equals to 32 plus 21 is equals to minus 11. Minus 11. So y is equals to 11 over 19. So therefore, m points coordinates we get, x coordinate is minus 52 over 25, comma, y coordinate is 11 over 19. Okay, no? Right. So we got the same m points coordinates. 8 plus 40 over 2, comma, 10 plus 3t over 2. Then balan, same m points coordinates in two different ways. So x coordinate equals to x coordinate, y coordinate equals to y coordinate. From both, you should get the same answer. You can get one of them and do it. So I'll take this one. I think second one is easy, no? So 11 over 19 is equals to 10 plus 3t over 2. So do a cross multiplication, 22 over 11 minus 10 divided by 3. So if you subtract capital T from this, you'll get 2 times 11 is 22 over 19 minus 10. This entire thing is divided by 3. So this gives you the T value. Simplify. 22 minus 10 times 19 is minus 190. 22 minus 190 divided by 3 times 19. Simplify කරන්න ළමයි. ඔයාලා simplify කරලා මට කියන්න. So y coordinates 11 over 25. 11 over 25. 25. This 12x plus 9y, no? 9y. So this is 25. This is 25. I'm at 25. So this is 25. I'm at 25. Okay. Simplify. Apa dah? ඔයාලා simplify කරලා ගන්නකො. ගන්න t value එක ටක් ගාලා. Someone simplify and give me the answer quickly. I'm not going to simplify. T equals to 76 over 25. This is the value that corresponding to OO dash. Now we can write therefore OO dash coordinates. Therefore OO dash, sorry, not OO dash. O dash points coordinates going to be 4t plus 4. No? O dash is 4t plus 4. No? So 4 t is 76 over 25 plus 4, comma 3t plus 5, 3 times 76 over 25 plus 5. Simplify and get the coordinates of O dash point. So draw this. First of all, draw this. You have a straight line segment L, x plus 4y minus 5 is equals to 0. X plus 4y minus 5 equals to 0. And here we have capital A point. Coordinates are given 1 comma minus 2. And A dash point is given on the other side. It's the reflection point of A. We need to calculate this straight line segment's name is L. Okay, this is L straight line segment. Question is, find the coordinates of A dash. Find the coordinates of A dash. Right, you just have to follow the process. Calculate the gradient of this. Join A dash. Find the gradient of it. Okay. You can take this intersection point as capital M or any other letter you like. Okay. And then find the parametric coordinates on A dash. And then using that, find the A dash point coordinates. To find that, we need the M points coordinates. In order to do that, you need this one's equation also. So last time the theorem aragina process right, I'll give you 5 minutes and then I'll discuss. Give it a try. Try. Okay, I'll discuss the question. Right, Mama discuss karanna. Now stop working and listen. I will give you time to write. Stop working and listen once again from the beginning. We are going to go through the same process, but I'm not going to go slow as we discussed the previous one because now you have a small experience, no? So we'll use that experience to increase the speed of the discussion a little bit for this part. Okay. Right. Now listen. So we have to find the coordinates of this capital A dash point. First of all, what I'm going to do is I will join A and A dash points 1 comma minus 2, right? So we need to find the coordinates of this reflection point A dash. This one is equals to this one. Why? It's a reflection point of A. Point A ke reflection ka meha paitha theen. A wagema, but in a different position we have that A dash point. Okay. Right. So number one, what we have to do? We calculate the gradient of L. So let's take the gradient of this one as M1 and gradient of this one as M2. L equation, if we take the L equation here, if we write it as y equals to mx plus c format, minus x plus 5 divided by 4, this is minus 1 over 4 plus 5 over 4. So therefore M1 gradient is equals to minus 1 over 4. Since L and A dash straight line segments are perpendicular, product of two straight lines, two non-parallel straight line segments, product of the gradients of two non-parallel straight line segments is equals to minus 1. So m1 is minus here, m multiplied by m2 should be minus 1. m1 is minus 1 over 4 times m2 is equals to minus 1. So from this we get, I'll write it here. From this we get m2 is equals to plus 4. So the gradient of this one is equals to 4. What is our goal next? Find the coordinates on this a dash parametrically. Now what I'm going to do is consider any point on a dash as x comma y. It can be any point on this x comma y. X comma y. How to write the gradient using this x comma y? Difference of y coordinates divided by difference of x coordinates. Y minus minus 2 divided by x minus 1. This is equals to the gradient 4. What is this? 4 means 4 over 1. Special cross multiplication. This is y plus 2 divided by 4 equals to x minus 1 over 1. This is a number will equal that to a number where t is a parameter. T is a parameter. This one gives you one equation, this one gives you another equation. From one what we get? Y plus 2 over 4 is equals to t. This implies that y is equals to 4t minus 2. 4 simple t minus 2. From the second equation we get x minus 1 over 1 is equals to t. This one gives you x equals to t plus 1. This is our x coordinate. Therefore, coordinates on a dash parametrically is going to be what? X coordinate is t plus 1, y coordinate is 4t minus 2. Any point on this a dash. Any point on this a dash. Okay. So I think last bottom part is not visible. Okay? It's any point on this a dash. Now, we assume that when t equals to capital T, we get the coordinates of a dash point because t can be any value. T get a specific value gives you a dash. That specific value we don't know, we'll take it as capital T. Assume when simple t equals to capital T, we get coordinates of a dash. So when a dash coordinates are equals to then capital T plus 1 comma 4 capital T minus 2, capital T plus 1 comma 4 capital T minus 2, right? This one's going to be capital T plus 1 comma 4 capital T minus 2. Okay. Now what we are about to do? Next what we have to do? We are going to calculate the coordinates of this point. I'll take that point as capital M. Calculating coordinates of capital M. That's the midpoint of what, Putha? That's the midpoint of this a dash. Why? There is a reflection point. So a to mm, m to a dash, distance must be equal. Now how to take it? How to take the coordinates of a midpoint? At the x coordinate divide by 2. 1 plus t plus 1. 1 plus t plus 1 divided by 2 comma minus 2 plus 4t minus 2. Minus 2 plus 4t minus 2 divided by 2. This one gives you the m points coordinates. So m points coordinates, simplify and write it. T plus 2 over 2 comma minus 4 plus 4t, or as 4t minus 4. 4 capital T minus 4 divided by 2. Let's just keep like this for the moment. Now I can get the coordinate of capital M point if precisely or as accurately if we know the equation of this AA dash. My goal is to find the equation of AA dash. Now calculate the equation of AA dash point. The AA dash is straight line segment. How to find the equation? We know a general coordinate, we know exactly one coordinate, we know the gradient. So using the we can take it. Difference of y coordinates, y minus minus 2, which gives you y plus 2, divided by difference of x coordinates, x minus 1. Difference of y coordinates divided by difference of x coordinate, this is equals to, what is it? This is equals to the gradient 4. Now do a cross multiplication and get the standard equation. We get, you see, x minus 1 take the other side, 4x minus 4. So we get y plus 2 is equals to 4x minus 4. So take all the terms to one side. 4x minus y is equals to plus 2 plus 4 is equals to 6. I'll take it as first equation. I'll take it as Apata, we have already 1 and 2 equations named here. No? I'll take it as third equation. Same process we did. Now I'm doing applying the process continuously. Hari. Now that's the equation of what? That's the equation of this AA dash. So I just subtract. I just took the constant to one side. That's the only change I did. Now I will recall the L equation below that one. So this is how we recall. I'm calling the L equation here. That's this arrowhead says that L equation. I'm calling it here. X plus 4y minus 5. I will take it to the other side plus 5. So we get x plus 4y is equals to plus 5. We'll take it as fourth equation. By solving this third and fourth equations as a pair of simultaneous equations, you get a value for x and you get a value for y. Those x and y values are going to be the coordinates of this capital M point. No? Coordinates of this capital M point. So what I'm going to do is, let's multiply the third equation by 4 and add that with the fourth equation directly. So if you multiply the third equation by 4, we get 16x minus 4y. Okay, 16x minus 4y plus x plus 4y. X plus 4y. This is equals to, if you multiply by 4, 4 times 6 is 24. 24 plus 5 is equals to 29. I'll directly write the answer. Minus 4 plus 4y cancelling out. 17x is equals to 29. X equals to 29 over 17 kilo now. X equals to 29 over 17. So now do another simplification and find the value of x. Multiply the fourth equation by 4 and subtract the two equations. These simultaneous equations, no simultaneous equations here, simplification. I don't think that you guys will make errors in that. Fourth equation, I'm going to multiply by 4. Fourth equation, let's multiply by 4 and subtract the third equation. If you multiply the fourth equation by 4, we get 4x plus 16y minus 4x plus y. 4x plus 16y minus 4x plus y. This is equals to, I'm multiplying by 4 this one, and from that I'm subtracting this one. All our simultaneous equations. If you multiply this one by 4, 20. 20 minus 6 is equals to 14. So plus 4x minus 4x cancelling out. 17y is equals to 14. So we get y equals to 14 over 17. 14 over 17. Capital M points, coordinates, right? T plus 2 over 2, comma 40 minus 4 over 2. same capital M points coordinates 29 over 17, comma 14 over 17. 14 over 17. So we get t plus 2 over 2 should be equals to 29 over 17. So do a cross multiplication and simplify. If you take 2 to the other side, 58 over 17 minus 2. So 58 over 17 minus 2 means 34 over 17. So 58 minus 34 over 17. No? So you get t equals to, take 2 to the other side, 29 times 2 is equals to 58, 58 over 17. Take plus 2 to the other side, minus 2. So 58 over 17 minus 2. 2 kilograms, if you take a common denominator 17, 17 times 2 is 34, 34 over 17. So finally you get 58 minus 34 over 17. 58 minus 34 over 17. I don't know whether it's visible for the students. So I will erase this part. Make a color. I'll write it here. So we get capital T is equals to 58 minus 34 over 17. So we get 24 over 17. So capital T is equals to 24 over 17. Okay, 24 over 17. So here now, therefore, A dash points coordinates we get t plus 1, t is 24 over 17 plus 1, 24 over 17 plus 1, comma, 4 times 24 over 17 minus 2. So A dash, this gives you 24 plus 17 over 17. 24 plus 17. How much is that? 34, 34, 41. 41 over 17. Comma. 4 times 24 is 48 minus 34 over 17. 48 minus 34 is equals to 14. 14 over 17. When 14 over 17 when can't be 14 over 17. No? Sorry, it's not 48. I made a mistake. It's not 48. 24 times 4, no, 80, 96. 96 minus 34. 96 minus 34, 62. Okay, check whether my simplifications are correct or not. So that is A dash points coordinates. Alpha comma beta. So this is that point. So I want you to calculate the coordinate of O dash point. O dash point ke coordinates kanda. These are this distance and this distance. So O dash is the reflection point of O. Now after this understanding, to do the other ones, you should be like expert ultra pro max in the previous 17 to 18, including this one 18 theories, in order to discuss from 1920 and onwards. Listen, what did we do? We'll start with the calculations. Stop writing and listen. Now change. I'm going to do a small change to make my simplification more easier. Okay. Previous I didn't do it. Here I'm going to do a small change to make my simplifications easy, because all the things are given in notations. Can't simplify like we do the simplification in terms of numbers. So let's take first of all M1. Let's take L equation. If I write the L equation equals to as y equals to mx plus c format, this is going to be minus ax minus c divided by b divided by p. So therefore, m1 is equals to minus a over b. Since m1 times m2 is equals to minus 1, we get m2 is equals to, here m1 is minus a over b, no? So this is equals to minus 1. From this we get m2 is equals to b over a. M1 is equals to minus a over b, m2 is equals to plus b over simple a. Now what I'm going to do is I'm going to find O dash points equation, O dash points coordinates parametrically. So let's write that. Consider any point on OO dash as x comma y. Difference of y coordinates y minus beta divided by difference of x coordinate x minus alpha is equals to the gradient is b over a. Special cross multiplication y minus beta over b is equals to x minus alpha over a. This is going to be equals to a parameter. T is a parameter. T is a parameter. So this gives us two equations. I'll take this as 1. We'll take this as 2. So we get from 1 x minus alpha over a equals to t, or else x equals to a simple t plus alpha, or else alpha plus simple a times t. From the second equation, y minus beta over simple b equals to simple t. This gives us y equals to plus beta plus simple bt, beta plus bt, or as bt plus beta. Therefore, we can get the general coordinate, general or as coordinate on OO dash parametrically. We get alpha plus AT, comma, beta plus BT. Alpha plus AT, comma, beta plus BT. Now what's next? We assume that. Assume when simple T equals to capital T, we get O dash. So that we can write O dash coordinates in terms of capital T. Alpha plus A capital T, comma, beta plus simple B capital T. Now we will find the endpoints coordinates. Find the coordinates of capital M. Endpoints coordinates are going to be, listen carefully. How do you find the coordinates of capital M point? Capital M points coordinates are, capital M point is the midpoint. How do we take it? Alpha plus AT divided by 2. Alpha plus A capital T divided by 2. Comma, beta plus BT divided by 2. So this gives you capital M coordinates 2 alpha plus A capital T divided by 2, comma, 2 beta plus simple BT, simple B capital T divided by 2. Now, what did we do in our previous calculations? Recall, what did we do? We did find the endpoints coordinates accurately by finding the equation of this OO dash. Previously, it was easy because we were dealing with numerical values, numbers. Simplifications are easy comparatively. The method prashna kotiyai. Simplifications complicated. It will take a lot of time to do the simplification because numbers it won't get simplified. We have to keep A, B, C, we can't simplify it. Then to find this capital T, I'm going to go for another approach. Instead of finding the capital M point coordinates by taking the equation of this O dash and solving the equations and getting XY coordinates of M, instead of doing that, I will go with this idea. Can you recall? We discussed the theory that coordinates of a point on a straight line segment satisfies the straight line equation. Coordinates of a point on a straight line segment satisfies the equation of a straight line. We can use the same thing in our previous questions also. Okay, I didn't do that because I want to remind the previous theories also along with this. So now I'm going to use the another theory and remind it. The capital M point is not just on OO dash, no. Capital M point is also on L. So the coordinates of capital M must satisfy the L equation because what's the theory? Coordinates of a point on a straight line must satisfy the equation of a straight line. So I can write, since capital M is on L, put a comma, M coordinates satisfies the equation L equals to 0. What is L equals to 0? Say L equals to this one, which means ax plus by plus c equal to 0 equation satisfies. In the place of x I can substitute the x coordinate, in the place of b I can substitute the b coordinate. So we get simple A times x coordinate is 2 alpha plus A capital T divided by 2 plus simple B times 2 beta plus B capital T divided by 2 plus C equal to 0. Now multiply the entire equation by 2 and remove the brackets. We get 2A alpha plus A square capital T plus 2 simple B beta plus B squared capital T plus 2C is equals to 0. Listen, na? Then balanna lassan pattern again heading. We'll take this capital T outside from A squared and B squared. So we get T times A square plus B square. This is equals to, take all the other terms to the other side, 2A alpha, 2B beta, 2C. Take the other side, minus 2A alpha, minus 2B beta, minus 2C. Now take a minus 2 as a common factor outside, we get capital T equals to, if I take minus 2 as a common factor outside, we get A alpha plus B beta plus C divided by A squared plus B squared. A square plus B square. Then ahang inna scene neka. Don't try to substitute this T in here and get O dash. Okay. In here and get O dash. It gives you a big expression. We'll try to understand the pattern. Okay. First of all, write this one, will you? Ek lassan to liyanna man kiyala denna. First. Summary. Now listen, na. In summary, now listen carefully. Let's take a straight line segment and the equation is ax plus by plus c equals to 0. There's a point capital O which has the coordinates alpha comma beta. We need to identify the coordinates of its reflection point. Its reflection point on the straight line. Meage coordinates gandu oni. What's the pattern to get it? Directly we can get it using a parameter like this. Then I'll have to erase this one now. I'll erase this and write it here. O dash point coordinates. We can write it like this. O dash. What's the pattern? Here, see the pattern. Alpha plus simple A times capital T. How the alpha? Coordinate of this point. If we are finding the O dash points coordinates, then you are going to take its parental points x coordinate here. Its parental point is O. Okay, x coordinate is alpha. at that width, always plus, at that width of this in this straight line segment, of this straight line segments, coefficient of x term A times capital T. Always try to use capital T or any other letter use command. We have to write that capital T separately. We can find that capital T separately. Okay. Comma, how to take the y coordinate? Y coordinate of the parental point plus y coefficient of this straight line times capital T. Where capital T is equals to, listen, this is a pattern. Make a mataka tiyaganda wenama. Minus 2 times, always minus 2 times. Substitute the O points or as parent points xy coordinates on the left hand side of the equation here. A alpha plus B beta plus C. Pattern this is what we call observational results. Then discuss right, divided by square root of, sorry, not square root, divided by sum of the squares of coefficient of x term of the straight line. This is a straight line, not O dash. Anittikagi. A squared plus B squared. What's the pattern? Hurry lazy. Okay. If I take an example, you see, if we take an example like this, let's say there's a straight line segment 3x plus 2y minus 5 equal to 0. Here we have a point. Make a plus 5 1, 2. We'll take that point as capital A. We need to find the coordinates of its reflection point A dash. We usually denote at A dash. Sometimes you won't get it as A dash or when not B kila. You have to understand if these two distances are equal, it's going to be A dash. We can easily write A dash equation without doing any of the process. We can easily write it. This one's x coordinate plus that one x coordinate is 1 plus coefficient of this x, coefficient of this straight line's x 3 times capital T, comma this one's y coordinate plus this one's y coordinate is plus 2 times capital T, where capital T is equals to minus 2 times. Substitute these coordinates in this. 3 times 1 plus 2 times 2 plus 5. Divided by square of this x term, square of this y term. 3 squared plus 2 squared. Simplify and get the t value from this and substitute in this, you get A dash. What's the t value from here? We get t equals to minus 2 times 3 times 1 is 3, 2 times 2 is 4, 5. 3 plus 4 is 7, 7 plus 5 equals to 12. Divided by 9 plus 4 is 13. This equals to minus 24 over 13. Substitute that value in A dash. A dash is equals to 1 plus 3 times minus 24 over 13, comma 2 plus 2 times minus 24 over 13. Simplify. A dash is equals to simplify and get the answer. I'm not going to simplify it. I'll simplify A dash answer. That's just a small simplification. Minus 24 times 3 is minus 72. 1 minus 72 over 13. 2 minus 48 over 13. So this is how we find it. So summary understand the pattern and do the summary. Understand the pattern and do the summary. Right? And then do that example and get the understanding.